workshop coming up this Saturday in 2 days. So come to that if you like. It's worth extra credit, and these things are popular. You learn hacking from Lan Che, who's running the hacking competition team. And so today, in 129S, we're down to Chapter 10, attacking back-end components. So let's start with that. All right, so we've talked about this quite a bit. You can have command injection. There might be a way your server-side scripts often call command line functions, which is an unwise policy. And if you do, you might do something like this. You make a command to print something like a directory of a directory, but you feed in a parameter that came from the user directory and just put it in a line of code. This is Perl, which is a little hard to read, but the end point is you're supposed to use it this way. dir equals public, so it'll show you the files in the public folder, but if you just put dir equals public pipe cat password, then the pipe will make it go to the next command, and it will cat password. So we've done this, you've done this in the projects, various kinds, in and out of the Web Security Academy. You're familiar with this. If code does take data from the user and incorporate it into a command line, then you can usually have command injection by just adding some punctuation marks to cause it to misinterpret some of the data as code. And this happens many times in the real world. HP OpenView had a command injection where you just put in a pipe and then a command. ASP, every language has this vulnerability. Here they are again, doing C directory and then a directory name that came from the user, so that's just asking for it. And so if you put in a normal directory, you get an output, but you can then just put in a directory, and down here you put the directory and IP config. So that'll give you, do an IP config down there. So, and PHP, of course, has a common flaw. The eval function executes a shell command, and the shell command might include data that came from the user, and if it does, then of course you can execute arbitrary code with the privileges of the web server, which are usually not running as root, but then you get one of those root escalations like the one I was just talking about in the news, and escalate from there. You usually have to put in some special characters like pipe or semicolon or ampersand for the injection to work, and there's other ways to do it. Backtick is another character that can do it. All right, and then of course there's a more common situation is blind command injection, where you can inject the command, but the output is never printed to the screen. So it can be hard to tell if it works, just like blind SQL injection. So what you can do is you can use ping to cause a time delay, or you can create some kind of network traffic going out to something you can reach, TFTP or Telnet or something like that, just like we did in the blind SQL injection. So NSLOOKUP had a vulnerability here. The app passed user input to it, and some of these characters were blocked but not greater than. So what you could do is you could send it an invalid domain name that included script. You could do NSLOOKUP of your script, and then it'll put an error message out that says, I can't find this, and it will execute the script and put the output of it there. So it's just a way to trick it into exfiltrating it. And we saw examples of that with SQL injection too, where you'd create an error message, and in the error message would be the data you're trying to exfiltrate. So if you want to prevent this, you shouldn't be calling the system at all. If you must, then make sure that you're not letting user input into there. What it should do is just have allow listing where you only allow certain options and nothing else. Or it's better to use APIs instead of passing to a commands to a command shell that parses them. Don't put user input into dynamic things. If you have to, then filter it with allow listing, where only certain known good things are allowed there. And then, of course, there's file path traversal. Here's something that displays a file name, a file in the browser with a file name at the end. And so if you use .. / you can move up into other folders. If permissions don't stop you, which they should, but if the permissions have not been set to limit the web server to only reach certain folders, then you can browse your way to other folders. You may be able to read or perhaps write to files. If there's a function that writes and has a file name parameter you can reach. And so if you can read, then you can find sensitive information like passwords and logs. And if you can write, then you can write something that will be executed later and get code execution, or you can write configuration files and so on. So there are file system monitoring tools. On real computers to check this, like Tripwire and other ones like it, that will just tell you if anything has changed. And until now, I've been yelling for about 2 years that they don't have these on routers and VPN concentrators, and they really need them because they're the number one things that get attacked now. And finally, Sophos just announced last week their new firewall with integrity verification, the remote. You can ask it, are all the files on this thing in their original unaltered state? It will tell you. I don't know how good it is, but I'm glad to see somebody finally doing this. They should all have that. They should have had it years ago. We really need them as soon as possible because they're all getting hacked, and we need some defenses on our edge devices. So if you want to find these in doing a security audit, then inject a unique string in every parameter, and then look through your file system monitoring tool to see if any files contain this string, to see if it's ending up anywhere. Here's a path traversal attack where they have a file name and they do .. Windows win any, just a file of no particular importance that's available on Windows systems, and then they show the contents of that file, showing that they were able to browse where they shouldn't go. So try .. and .. You can URL encode them so they are less likely to get caught by a filter. And you can use 16-bit Unicode and double URL encoding and overlong UTF-8 encoding, just more and more complicated ways to encode those to stop filters from working, which is why deny lists don't work very well, because it's pretty easy to modify the input so it won't match the stuff in the deny list. These, like I say, these things are technically illegal, but they're often accepted anyway. And you can have doubled things where one like a .. is inside another .. so that even if the filter tries to remove it, if it doesn't iteratively remove it, you'll still have one left. And you can put null characters in. We talked about this before. So if it wants an image, you could put it, even something that ends in .jpeg, but C-based code, like the web application firewall, will terminate it here and interpret it as any, so you can you might confuse for various filters. So if you can read things, then you can find data sources, source code, log files, and so on. Lots of good things you can find if you have read access on a server. And write access, you can modify scripts and things that will eventually be run, like login scripts and so on. Sometimes you can write a script in a web directory with execute permissions and then execute it yourself by just going browsing to it. All right. And all right, so if you want to prevent these, then of course you shouldn't pass user-controlled data into the name of a file or anywhere in the path. Again, if you have to, then just let the user choose from a list of known good inputs. If you must allow users to submit file names, then what you have to do is, after all decoding and decanonicalization, meaning turning it from like that %52 into normal letters, then check for forward slashes, backslashes, and null bytes. And the most important thing, it's amazing people don't do it, is if you find anything suspicious, stop. Don't try to clean it up and use the remaining stuff. That just blop. Go back to the user, say, that was a bad input. You have to give me a better input. That sort of thing. After this, use file system APIs to verify that the file name is okay and that it's in the expected directory. That's another good policy. And there are tools to get the full path or the canonical path, so you can tell if you're still where you should be. So if they've somehow snuck in .. you'll know they're not where they should be. Another thing you can do is a cheroot jail. These have been around for decades. Before there were virtual machines, there were cheroot jails. You can change the root of your application to be in a folder, and then it cannot reach anything outside that folder. So you have to take whatever system applications it needs and put a copy in the folder, just like a little virtual machine. They have the apps they need in the folder, and they have all the data files they need in the folder, and they can't see outside that folder at all. That's a nice way to prevent this sort of stuff, file traversal. And that's been around for, like I say, decades. And of course, you can do it in Windows too by mapping a drive letter to a folder. That's a way to make a cheroot jail. And you can, and your defenses should be logging and alerting when bad things happen. So file inclusion is a big issue to reuse code. You make include files. I use them in PHP. Everybody does. Then you include this file in your other file. The problem is your include functions can include from elsewhere. So you can include, like you want to say, get your country and include country.php. I'm including data from the user into an include file so the attacker can change the country to full path to a remote file. And now I'm adding a remote script from an attacker's server into my page. That's remote file inclusion, which is pretty awful. And so local file inclusion is simpler, where you can just include an unexpected file that's already on the system, which is not as powerful as being able to inject malware, but still it's a bad thing to do, and you might be able to expose confidential information and so on. So if you want to find these, then test in each parameter a URL and a web server you control. You can look at your server logs to see if the requests are going there, non-existent IP address for a time delay, and if it is vulnerable, you can put a malicious script on the server and then run it. And again, try a known executable on the server, a known static resource, sensitive resources, and so on. See if you can put these things in parameters, and if they work. That's how you detect these things. All right, let's try a Kahoot, which should be 10A, right here. All right, so what defense detects file system modifications? Tripwire, been around for decades. A little bit irritating to set up, but it will tell you when system files change. All right, so what character performs command execution immediately? The backtick, an irritating thing about bash command line. You put something in the backticks and it will execute immediately and put the output in the command line. So I don't like using it. I prefer to use dollars parentheses, which is the old-fashioned way to do it, because it can be copied and pasted and understood better in different contexts. This backtick tends to confuse people, but it is the standard. A lot of people like to use it. All right, what defense puts the web server in a restricted file system? That's what a cheroot jail is, like a virtual machine. Your server is trapped in this little area and it can't go out of it. All right, so what vulnerability is caused by eval? A source code scanner will flag you just for using eval at all, saying, no, Don't use eval. Are you crazy? Yep, you get command injection. Eval passes that command to the system to execute, and that usually means you're going to get in trouble. All right. All right, so then there's XML. If your server is using XML to transmit data and interpret it at the other end, this is quite common. It's just a way to format data, and AJAX-based applications like Google Maps use this, among other things. And so a client will send a request with a post, and down here is the XML. You have these things that look like HTML tags, a search object and a search term inside there, and the search term is nothing will change. It's a plain text way to send data up, and you put it in these labeled containers, so you know what they stand for at the end. So they'll send a search to this search page, saying nothing will change, and the answer will say no results found for it, and the answer also comes down in XML format. So it's just a way to format data. But anyway, it has its own particular weaknesses, and one of them is that there are special features available in XML. You can define an entity called testref and testref value. You can declare like user-defined shortcut variables you set equal to some value. So now you define this thing called testref to stand for this, and every place you put ampersand testref, it'll put in that value. So this is, you have the ability to define a variable. And so there's some nice demonstrations like Macinetics. So here, if I post foo hello world / foo, then I'll just get the answer from the server will just be hello world. All right. This is a web application that takes input, parses it, and outputs the result, just sort of an echoer. But if I take the same web application and I send up hello bar, and up here I define bar to be world, then again I'll get hello world. But this is a literal hello, and this is copied in by expanding the user-defined entity. So what you can do, of course, is I can now set bar to world, and I can set T1 to 2 bars, and T2 to a bunch of T1s, and T3 to a bunch of T2s. And as you can see, I could do this a bunch of times until I'm getting hundreds or thousands repeated. And this is used, among other things, for denial of service attack. You can just define, with a small amount of code here, you can set up something that will waste a huge amount of server time and bandwidth repeating the same thing over and over. And then you can just make a system file. Now this entity stands for the contents of that file. So when you just repeat the XXE, it puts in the contents of the file. So that's local file inclusion by means of XML external entities, they call it, these XXEs. And you can also go and do remote file inclusion. You can put in a URL, fetching a file from some other server, and the contents of that file will appear wherever you put the tag you gave it. So, pretty dangerous. All right, so we saw that. It'll fetch something from a remote server, or local server, or a remote server. The XML parser will, and the contents will appear in the output. You can also specify the port. So you can use this to scan what's going on behind the firewall. You ask it to now please go fetch a file on port 25, and if you have services running that will accept HTTP requests, which some services will, others won't, then you can get the response to that. So it's not as good as actually having a real port scanner like Nmap, but you can do some degree of port scanning, and you're going to be working from the web server, wherever the parser is, which is inside the firewall, and going to see parts of the network that you probably can't see from the outside. You can also, here's one of the denial of services, you can just set it to an endless stream of random bits, dev random, so that'll waste a lot of time. And then you can inject into SOAP. SOAP uses XML to send data to the server. So if you have a banking app, it might send a series of parameters up to a server, like from account to amount, and submit. And then the server will take that and then pass it on to some banking server that has the information. So here it'll pass it on, and cleared funds will be false. This is added by the intermediate server saying, okay, the user wants to move this money, but I have not yet verified that that money is really in the account. So I'll send this request to the other server, which is going to tell me whether perform the exchange if it's really there. And so now what you do is you inject XML. Now I only control the amount, but if I can put in text in the amount, I can put in all this red stuff in the amount. And so I control the amount and the to account. So in the amount, I put all this junk, and in the to account, I put that junk. So now it's going to have the cleared funds true in the request, and the to account is going to go to this account here, not the one I actually sent up. So that's the game. It looks like I sent a blank to account, but I'm able to send it to a different place. Or no, I removed this to account. And I'm not, so there's the resulting soap master. I'm a little confused about what happened to the to account. Let's see. So down here, to account, okay, it was that number. Okay, fair enough. Anyway, the point is I was now able to add this parameter, cleared funds, to my request, which may be forwarded to the server now. And now you have the weird situation where it probably is going to add another cleared funds false. And this is a fundamental problem with all web apps, is that if you have if you have the same parameter defined twice, the behavior is not defined by the specifications. So you can sometimes get away with murder that way. Anyway, so and the way to find it, all you have to do is stick in like a closing tag or a comment tag and see if it breaks the app. If it starts giving you weird errors, that would be a clue. Here's some things you can put in. You can try just like mentioning start or close of a parameter, of a comment. That should remove a whole bunch of it and have some kind of unexpected results. And if it filters the data to prevent this, then you can HTML encode these characters when they come in. Anything coming from the user should not be allowed to have less than or greater than signs or slashes. Those are meta characters to indicate things like comments and the opening and closing XML tags. So you should just URL encode them. So all that does is mean display this on the screen so it looks like a less than sign, but it is not a less than sign in the source code, so it's not interpreted as a meta character. And then you can inject into backend HTTP requests. This is a common problem. So if you have user-controlled input in a URL, and user controls location. So I have this thing called location here, and I can send a post telling it for some reason a location field. Then what I can do is I can change the location and put a port number. And now it's going to go to that URL, and what I'm going to get back is going to be the response to that, which is the OpenSSH header field. So, again, I'm using it to do a sort of port scan behind the firewall. That's using the app as a proxy. All right. And then I mentioned parameter injection. If you can add extra parameters to your request, then you may get away with things because even though the app adds more copies of that parameter, you don't know which one's going to work. So for example, we said before, the front-end server can add cleared funds equals true to the request, and then the result will be we'll send something with cleared funds equal true in it as it goes ahead. So that might fool it. And like I say, if you define the same parameter twice, nobody knows what you should do. It's not covered in the rules. So some people just use the first one. Some servers only use the second one. Some servers add them together. Some servers create an object like an array with all the values. And so it will have unusual effects. And sometimes you'll be able to get away with things this way. So the original backend request had cleared funds equals false. The final request had cleared funds equals false and true. False and present 3D I think is equals or something true. It made a list with true. Let's see, cleared fund equals true. All right, that's the request, and there the backend request now has cleared fund equals true. In this case, cleared fund equals true just went through. The backend didn't add the other one, but it could have. Anyway, another weird thing about Apache in particular is they perform URL rewriting. And this seems to me to be the way people invent this REST stuff. I don't know why anybody does this RESTful parameters, where you put parameters in and they look like folders, but if you do, you need to somehow parse them out, and they tend to do it with URL rewriting, which works by sort of regular expressions, looking for patterns. And here's the rule. You can tell it's regular expression because it's mighty hard to understand, but this is going to look for the pub user, and then it's going to look for folders defined here. And the things that are there are going to be interpreted as parameters. So it changes this request into that, which is why I don't know why anybody ever did this anyway. Pub user Marcus, why didn't they just make you do this? Mode is view, name is Marcus, that sort of thing. But people do that. And so that's what mod rewrite does. And of course, it can be fooled. So if I change it to this, if I add extra characters in the thing that's going to be interpreted as a parameter, then it's going to allow me to have a second parameter I've injected here, mode equals edit, which it didn't intend to let me specify. And another one is a mail server. Mail servers just take lines of text with carriage returns, and those are interpreted as all the email messages to send. So you can do an attack like HTTP response splitting. So if I have a feedback form, I can fill in this form with email address, subject, and comment and submit it. What it's going to do is create this thing to the, I didn't get to control the to address because this is a feedback form. It's always their feedback email, then from here with a site problem, and so on. So what I can do is I could just here, in my email address, I could put in a carriage return and then a BCC, because it is a plain text protocol. So if it will let me insert a line feed here, then I can put an extra line they didn't intend, like a BCC here. And then what I can do is here, subject site feedback foo. Okay, this is a normal one working as normal. But if I can now insert in my subject, I can put in carriage return line feed, and more carriage return line feeds and more carriage return line feeds, and the end result is now my one email will turn into two emails. Emails end with a period followed by a carriage return, and you then have another email, and the email server will send both of these. So you intended to let me use a feedback form, but now I can use your feedback form to send spam to anybody I want. And that's the kind of vulnerability that happens. It's not quite as bad as just having an open SMTP server that lets anybody send any mail through it, but it amounts to a very similar vulnerability. If it's going to allow people to put in carriage returns and line feeds, then they can do all this to you. So try every parameter, see if you can get away with it. Try to put in new lines, is the most important thing. And to prevent this, you got to validate the data, make sure the email addresses are valid addresses without any extra junk like new lines, limit the length, and so on. Don't let people inject a single dot, and don't let people inject any carriage return line feeds. These are good ways to prevent that particular attack. So let's try another Kahoot. Trend B. All right, so which attack sets the same value twice? That's parameter pollution, they call it. All right. Which attack works on Ajax-based apps? AJAX stands for asynchronous JavaScript and XML. So it's this XML attack that works, and it gives you powerful graphics like Google Maps, but it is therefore vulnerable to XML attacks like XML external entities. All right, which attack injects XML and HTML comments? That was the SOAP injection, to inject into Simple Object Access Protocol, where you could use comments to remove some code the developer put there and inject XML tags to add extra parameters that the developer didn't put there. All right, and which attack uses a line containing a single dot? Yep, that's SMTP, where that mark indicates the end of an email.